When can I come in an advisor to look over my quiz?
Ours are made up. I just need to check with Miss Cross, make sure that her students have all made them up, and I'll email her right now to see.
Okay.
So my guess would probably be on Tuesday, because
Perfect.
you can't sign up for anything at this point for this week anyway, so.
Right. Okay, thank you.
No way. No, but I use sweatsuits a little bit.
2, 3, 1, 2, zoom out. Thompson, Brandon, Gray.
Yeah. People are wearing these sweatsuits. I don't really see that.
Brooke. Whitney. Captain 2. Brady.
Good morning, FHS. Today is Tuesday, February 6th, 2024. Would you please join me in a minute of silence? Please stand if you are able and join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you, and have a great day.
All right. Good morning, guys. We've got a couple things on our list to do today. First up, we're going to look at 87, which is the one that says properties of integrals in the top right. So the first 6 statements there are some properties that you're supposed to know, and I think you actually already know those, but I felt like this was good practice. So in just a second here, we will go through those 5 questions, all the parts of those 5 questions first. just in case there's any of those properties that you were not aware of or a little unfamiliar with. We can hopefully clear that up today. The other handout I gave to you to pick up is number 88, and it's actually the test review, and I'm just trying to give it to you guys a little bit early because based on how you did on the last exam, you might want to, some of you might want to start preparing earlier and kind of spacing out your studying a little bit more. So I'm trying to provide that for you. But for today, I'd at least like to do FRQ1 with you. So that way we've got a chip or a piece of that done, and at the same time reviewing some of the stuff that you need to be aware of. And then finally, I've got a book assignment for you on use substitution. It would be 2, 4, 6, 8, 10, 11 questions. So at this point, we did some notes on use substitution. We did a book assignment together that was like 9 or 10 questions, and you did those 3 Khan Academies. So you should be feeling pretty good about use substitution, and especially after you get that little bit more practice in 89, you should be feeling like you're in pretty good shape with those. Okay, so jumping right into it, let's go ahead and look at these properties. Now I'm actually going to, might seem backwards to you, but suggest for you not to read those 6 properties on the top, at least to start off. Again, those are ones that we're supposed to be aware of, so you can always come back and look at those later. But what I'd like you to do for just a minute or two here, question 1 has 4 different parts. It's not multiple choice. 1A, 1B, 1C, 1D. So using this information, those 3 hints, you should be able to answer those 4 questions. So I would like you to try those before we discuss them together, and that should help emphasize the ones that you don't know well enough. And all of these should be pretty quick, so I'm not going to give you a ton of time. If I'm not giving you enough time, that is also an indicator that you're not as familiar with those properties as you should be. I guess if you work super fast, you can move on to question 2, but I just need you to do question 1 first, and then we'll check that and then move on. Okay, so I'll start us off here. So A, if you're trying to integrate from 2 to 2, there's 2 ways you could think of this, but you should pretty much instantly know that that's going to be 0. Either A, you can think of this as area under the curve. If you start at 2 and end at 2, your figure's not opening up at all, so it's not going to create any area. Or you could think the antiderivative of G, which we don't know what that is, but we also don't care, because you're going to plug a 2 into it and get some number, then you're going to plug a 2 into it, get the same number, and then you're going to subtract those. Some number subtracted by itself ends up being 0. So anytime the bounds are the same, it should come out to be 0. For part B, you need to be using this one to come up with -8. So if any time you want to switch the bounds, instead of 1 to 5, if you would prefer it to be 5 to 1, it's going to be the same value, but you need to multiply it by -1. Similar to like the slope formula when you talk about rise over run. Run implies you're going left to right. If you chose to go right to left, you would need to do negative whatever your value was. So myself, typically I like the smaller number to be on bottom and bigger number to be on top. So when that's not the case, I usually just pull a negative out front and then switch those. I think this one comes back up again. Part C, there's a number 3 here, but again, a constant can be dealt with after a derivative or after an integration. Not if it was plus 3, but at times 3, it just makes it 3 times bigger. So it should have been 3 times bigger than this, negative 12. And then the last one should be 10, excuse me. 10 because if you know the area from 1 to, well, if I try to do a visual here, from 1 to 2, it has an area of negative 4, but from 1 to 5, it has an area of 6. Then you would want this full area 6. Take away how much of it you don't want. If you want the area from 2 to 5, you don't want to include the area from 1 to 2. So you subtract away negative 4. 6 minus negative 4 is where I'm coming up with 10. Again, usually on these question types, and I didn't give you this hint, but sometimes thinking about it as area under a curve kind of gives you a visual in your head, and you can kind of see how those pieces fit together. Okay, any of those 4 you'd like me to go over one more time? Okay, of course, my suggestion is any of those that you struggled on or missed, circle them and look back at them for a minute as part of your homework. But move on to question 2, please. A couple new clues and 4 new questions. Again, some of them should be very quick. There is a couple on here that'll take a minute, I guess, but I've given you time to try them to make sure that you do understand these. Okay, with this one, I will go ahead and just share all the answers first and then come back and explain how I got them. That way, if you're getting all 4 right, you can go ahead and keep on going. You don't need to listen to the explanation if you got it. So I went from 2, bless you, to 9, to negative 6, to negative 2. Okay, so A, this is going to be negative 2. Again, you can bring this out front. It's negative 2 times the area from 1 to 9 of f of x. So I did negative 2 times this. Negative 1 times negative 2 gave me positive 2. This one had more than one term, so we need to do those separately. The area from 7 to 9 of f of x was 5. The area from 7 to 9 of h of x was 4. Add those together. 5 plus 4 is where I got the 9. Okay, C wants to know how much area there is from 1 to 7 of f of x. So you needed to pit these two against each other. If you know how much area there is from 1 to 9, and then you just want to know how much area there is from 1 to 7, you need to take the area 1 to 9, subtract off however much area there was from 7 to 9, which is why they gave you this piece. So -1 minus 5 gave me -6. And finally, I guess similar to this one, 2 times the area of f of x from 7 to 9 would be 2 times 5, so this part should have been 10, minus 3 times the area of h of x from 7 to 9, which would be 3 times 4, which would be 12, and 10 minus 12 gave me -2. Any of those 4 you'd like me to go over again? Okay, then go ahead and try question 3. Okay, you're starting to be done on this one. Honestly, this is a little bit of repeat, and I think they're just kind of throwing one more thing at you. They're trying to get you to see that the letters here really shouldn't matter. To do the antiderivative of f of u, you're going to have some u stuff in it, but then if you plug in 2 and plug in 1 and subtract it, it all comes out to be a number anyway. Whereas if you did the antiderivative of f of x, it's going to have some x's in it, but then if you plug in a 2 and then plug in a 1 and subtract those, it comes out to be a number anyway. So if you're plugging in 1 and 2 into the same function, doesn't matter if the variables are different, in the end, the numerical answer should be the same. So this is exactly the same for this one. This is the same times the square root of 3. Again, constants, just make it that much bigger so you can deal with it. 5 square root of 3. You can multiply it by whatever the integral is. This one is the same as this, except the bounds are switched, which means it should be also equal to 5 if you multiplied it by -1. And this one is a lot like b, but the constant is -1. So -1 times the area of 1 to 2 of f of x would be -1 times 5, or -5. Again, a tiny bit of repeat, but mostly that one's about realizing that the variable doesn't matter there. Since you're plugging in numbers anyway, the numerical answers would come out to be consistent. Any parts of 3 you would like to discuss? Okay, 4's only got 2 parts, so give you a little bit less time here, but try those 2. Okay, on these two, I got an answer of 6 on both of these. So I think if you got the first one, you probably get the second one as well. But again, this one's asking for the area from 1 to 3. So they don't give you that information, but they do tell you the area from -1 to 3. So if this is hard for you to visualize, again, you can try to just kind of give yourself a little picture here. From -1 to 3, it has an area of 6. And then from -1 to 1, it had an area of 0. So to know the area from 1 to 3, you should take the area from -1 to 3, subtract off the area from -1 to 1, but 6 minus 0 leaves you with 6. Then this part of B switches the bounds, so it should be the same answer as part A, except negative, because it switched the bounds. But then it introduced another negative, so -6 goes back to being +6. Okay, either one of those you have a question on? Can y'all do this part A in your head, or do you try to draw a picture to visualize it? Okay. All right, I want to give you a hint on 5, because there's a lot of parts here, and just in case you had trouble getting started, I don't want you to not be able to do any of these. So again, I've said it about 5 times already today, but integration visually can be thought of as area under curve. Integration does a lot of other things. But notice they don't give us any hint in question 5. They want to know from 0 to 2, this is F. So basically they're asking how much area is there from 0 to 2. So from 0 to 2 would be all of this stuff. That's a quarter circle. So pi r squared would be the area of a full circle. Divide it by 4 if you want a quarter circle. And the radius of this is 2. So you should end up with pi? Question mark?
-pi.
Very good. It's below the x-axis, so it's not pi, it's -pi. Anything below the x-axis is opposite, negative. Unless it was already negative for some reason, and then it would become positive. But again, anything below the x-axis is negative, anything above the x-axis is positive, so be careful with that. Your geometry formulas are not going to do that part of it for you. Okay, so slide over, try B, C, D, E, and F. Of course, there's more parts here, so I'll give you a little bit more time here, but we'll make sure that there's nothing else. Again, I feel like you guys should be able to do all this before today. I know some of it's not as easy as the other parts, but just in case some of this doesn't feel very familiar, just helping you identify that. So. Okay, I think that should be close to time, but if it's not, you at least saw where you were kind of slowing down. So, at some point in this question, you needed to find the area of all these parts. So, I already had this one, so I went ahead and labeled it in there. At some point, I did the area of a triangle formula on this guy to get 4, positive 4, because it's above the x-axis. This is also a quarter circle. I can see it's the exact same area as this guy. So this one is also negative pi for this part. Negative because it's below the x-axis. And then over here, there was one more triangle below the x-axis, and that triangle had an area of 1. So if you want to know from 2 to 6, that would just be this part. That would be 4. From negative 4 to 2 would be this negative 1 minus pi minus pi. So negative 1 minus 2 pi. From negative 4 to 6, that would be this whole thing. So negative 1 minus pi plus 4. You could at least combine the minus 1 and the plus 4 to be 3. So 3 minus 2 pi. Alright, this one is absolute value. So you would have to keep in mind that that means you want everything to be positive. From negative 6 to 4, I've got a negative 1, but make it positive. A negative pi, but make them positive because of the absolute value sign. And then a positive 4. So that one should be 5 plus 2 pi. Okay, and then F, I think it's probably going to have the most mistakes here. You are going to be tempted to say 5 minus 2 pi. And if you did that, I can tell you what your mistake is. But again, that's just, sometimes students go a little bit too quickly here. Well, the first part of this you already did. From negative 6 to 4 of f of x, we did that right up here. So we already knew that part was 3 minus 2 pi. This doesn't say add 2 to it. It's not plus 2. If the plus 2 was outside the integration, then sure, you're going to add 2 to whatever you get from the integration. But the 2 is part of the integral. You couldn't get that from here. You have to do the antiderivative of 2, which would be 2x, and evaluate it from negative 4 to 6. So you needed to plug in 6 the first time to get 12, plug in negative 4 the next time to get negative 8, and then subtract those. So you end up with 23 minus 2 pi. But once again, that plus 2 doesn't mean you add 2 to your answer. The plus 2 is part of the integration, so you had to do the antiderivative and evaluate it by hand. That part of the question was not in the figure to the left. Alright, so please, while this is fresh in your head, circle the couple of questions that you found to be the hardest and make an effort to look back at those, because even if they don't show up on our test, all of this type of stuff shows up on the AP exam, so it's good for you to know it. Alright, well, I'm sorry, is there anything that you guys want to ask about this before we move on? Okay. Then let's look at your review here. Again, I'd like to just do the first FRQ today. It's got 3 FRQs on the front and then kind of an assortment of questions on the back. So again, just a heads up, your next assessment might be at the end of next week. I don't remember. It's on the agenda, our date for it. But it's all the stuff from your last quiz, anything from that's fair game, and then really the only other thing added to that is U substitution. So you guys should be feeling good with U substitution, or pretty close to feeling good with U substitution. We just have a little bit of time to really solidify and make sure that we understand all of these concepts. So, and the closer we get to the AP exam, the more and more FRQ practice we will do, because typically students don't usually think the multiple choice is too difficult, but as you guys have seen, FRQs can vary. Some FRQs are okay, and some FRQs are just extremely hard. So the ones that we can at least anticipate to be on your AP exam, we can at least practice those, and so then they become a little more manageable. All right, so this one I would like to do with you guys. I know you're tired today, but it kind of helps me see what you get and what you don't get, and maybe what kind of practice we need to try to squeeze in when we do get to AP review. So the first one says a particle starting at the origin, I'm just going to write that down as a point before I forget, travels along the x-axis. So x-axis, there's some particle that's just moving back and forth, so left or right. And he has a velocity that is this function for any time that the time is positive, which just kind of goes without saying. If you're talking about time, you typically don't go backwards on time. Okay, so for 10 seconds to yourself to think about it before someone says it out loud. If we have velocity and a point, part A wants to know what equation gives us s of t, which represents the position of the particle for any time t. So I want you to think about, what do you think the process should be? Should we do a limit? Should we do a derivative? Should we integrate? What should we integrate? What should we take the derivative of? Think about what the process would be. You don't have, I'm not going to give you enough time to do it on your own. I've given you enough time to think about what you would, what your gut reaction would be. And then we can correct it if need be. Okay, so this is where I need y'all to tell me, how do I go from velocity to position? Okay, so we could integrate. And again, I didn't give you time to do it, but you do need to copy it down, please. The thing I can take the derivative of to get e to the t would be e to the t. Now, we can use a calculator on this, by the way. It says calculators allowed for FRQs 1 and 2. The antiderivative of -6 would be -6t. How do I know it's -6t and not -6x? Right, that's what this d of t, that's why that's important, so that you know that you're talking about t's and not x's or something else. I know there's another t over here too, so that's also a help. Okay, and I need one more thing. Plus c. But remember, they gave us a point, 0, 0, so technically we should be able to solve for this. The position is 0 when time is 0. Oops. Be careful, e to the 0 is not 0. Anything to the 0 power is 1. And again, you have a calculator technically on this question, so I guess you could plug that in if you felt unsure. But so in the end, part A should be e to the t minus 6t, and then it looks like c became -1. Okay, everybody all right with that? You need to know how to go from velocity to position. Okay, so same thing with part B. I'm going to give you a couple moments to think about in your head what you think the process should be so that you can test out your gut reaction and see if you're on the right track. Part B wants to know, with that information, how could you go about finding the acceleration function? Okay, so how do we take any of this stuff and help us get acceleration? Right, the derivative of velocity gives you acceleration. The derivative of e to t is e to t, and the derivative of -6 would be 0. I think that's all it asks for. Yep. Okay with part B. All right, and then part C. put some thought into how would you decide when the particle changes direction? When does the particle change direction? So think about it. What are you supposed to know to be able to do that, and what do you think the process is going to be? Again, you don't need to start it, just think about it. Okay, so what you need to know for C, if you care about direction, then you care something about velocity. The thing that you need to remember, I don't know that this is going to be important for showing our work here, but when velocity is positive, that's when something's moving to the right, and when velocity is negative, that's when it's moving to the left. So, bless you, it might be changing direction when velocity is what? 0. If it's changing from positive to negative or negative to positive, that's when it's changing directions. Now, the reason why this is a maybe is it could be going left and then be at 0 and then going back to being left. I wouldn't call that changing directions. So first off, we need to figure out when does the velocity equal 0? Well, we have the velocity function from earlier, or no, they gave it to us, didn't they? Okay, so you do have a calculator, so I guess you could solve that with maybe equation or solver or graphing. You need to be able to do those things anyway. Personally, I would probably just add the 6 over, and I would just solve this by hand myself. To solve for exponential equation, that's where you would do something like take the natural log of both sides, because then the variable you're solving for is an exponent on something you're taking the log of. The variable can come down out front. We're going to need to do that algebra process here in the next unit we get to anyway, so if you don't remember that, it's not that big a deal. And natural log of b is 1, so there's only one time where the velocity is 0, so it might be changing directions at the natural log of 6. Natural log of 6 is when the velocity is 0. Again, since this is a calculator FRQ, you could use a calculator to solve that part. You don't have to do that part by hand. I honestly just thought doing it by hand would be quicker. But I am getting my calculator now because I want to kind of know what this is as a decimal. If you go the decimal route with your calculator, make sure you're doing 3 decimal places. It's implied your AP exam expects 3 decimal places. Doing 2 or 4, you're going to lose points unnecessarily. So, I don't know. I would try something to the right of that. This is the only time it might be changing directions. So, I would maybe plug in 2 into velocity. E squared minus 6 is positive. And when velocity is positive, I know it's going to the right. And then maybe try something to the left of that, like 1. E to the first minus 6 is something negative. I don't really need a calculator for that one. You guys should know that E is about 2.71 roughly. So 2.71 minus 6 is going to be something negative. And when velocity is negative, it's going to the left. So now I think we just need to state what our answer is. When does the particle change direction? Alright, so you could either say that, or since this is a calculator FRQ, again, they will accept if you do 3 decimal places. Oops. And your 3 decimal places can either be rounded to the nearest thousandths, or you can truncate. They're very flexible with that part of it. And assuming that they want some justification here, my justification would be, again, I did all of this to help me kind of organize my thoughts. This oftentimes is not enough justification. I know that it's switching directions here because at that time, velocity at this time is changing from negative to positive. It's much better to write 5 or 6 words there just to be very clear about why we think that's the spot that it's changing. Again, this type of stuff can sometimes count as justification, but a lot of times you guys don't put enough stuff. Like you don't put this and you just have an arrow left. Like, how do you know it went left? I mean, you make a lot of assumptions about what we can assume. Okay, so to finish up part C, any part of that you think you would struggle with still after we went over it? Okay, so next to the last part is the particle speeding up or slowing down at t equals 1. T equals 1 and t equals 2. So again, just think about how would you approach that question. What work do you think would have to be done to figure that out? Okay, so it's tempting to think about acceleration. And you have the acceleration function from part B. So I could plug in, that was just e to the t, is that correct? For acceleration, okay. So this guy is about 2.718. Oh, I guess I should know that because it's just e. Or e squared would be about this. So if you're only looking about acceleration to see if acceleration is positive, that's not enough to know whether it's speeding up or slowing down. This tells me the rate of change towards the right is increasing because these are positive. But the particle might be moving to the left, and the rate of change towards the right would be like you're hitting your brakes or something, like it's pushing back in the other direction. You also have to test velocity so we have that function. It was given to us in the beginning. So plug in 1 and plug in 2. Okay, so during which one of these times is it speeding up? Very good. Over here it is speeding up during these times because V of 2 and A of 2, what's special about those? Right, same sign, or you could say both positive is fine also. But over here, since this guy's velocity is negative, that tells us it's moving to the left, but his acceleration is positive, which means the rate of change towards the right is increasing. So he's not speeding up, he's slowing down towards the left. So this one would be slowing down because V of 1 and A of 1 have different signs. Again, if you want to know if something's going right or left, you only care about velocity. If you care if it's speeding up or slowing down, I know that sounds similar, but it's not the same thing. You care if it's velocity and acceleration have the same sign. Okay, on to the last part so that we can move y'all on here and hopefully keep you from having too, well, you guys have the extra 10 minutes. You probably won't have much homework, if any. What is the total distance traveled by the particle in the first 5 seconds? So a common mistake, although you guys have done pretty good with it, is you've got two functions to look at up there. You've got a velocity, well, you've got three. You've got velocity given to you, you've got a position equation that you found in part A, and you've got an acceleration function that you found in part B. If you integrate acceleration, this is calculating the change in the function that's right below it. This would be the change in velocity. If you want to figure out how much change is happening, change in position, which is distance, you should be integrating velocity. Integrating velocity gives you the change in position. However, if you do exactly this, it's still not quite meeting what we need. We need the first 5 seconds, so from 0 to 5. But the problem is, if it's going right, it would be adding to your total distance, and when it goes left, it's going to be subtracting from your total distance. But whether you're going right or left is going to add to your distance. So the keywords there are total distance. You would need absolute value. And unless it's a graph type of question like we saw at the end of the first handout this morning, your AP exam, so us as well for our class, we do not make you have to integrate any absolute values by hand. This is a calculator question, so you really just have to type it in. You better know where the absolute value signs are so that your calculator can do that. And even my calculator took a second here, because that's not easy for it to do. It took my calculator 5 or 6 seconds after I hit enter. I really should say that's so many feet or miles, but the question never specified, so not a great one for practicing units, but all good parts of potential FRQs. Anything about this first FRQ that you guys want to clear up before we go on? Yes.
For part C, could you short on the calculate just see where it starts and then
Part what?
part C.
Part C?
Could you graph it and then see if it's like goes from below the x-axis to above the x-axis?
You can. For your justification though, you're going to need to, don't say it was above the x-axis and then it was below the x-axis. You need to say the velocity went from negative to positive. But yeah, you can use the graph as long as you can convey that information in your justification. The problem with referring to a graph is you guys don't often say what graph you're looking at. You don't often say why does it matter that it crossed the x-axis. What is it, who cares that it was above the x-axis and then below the x-axis? Like when you go that route, sometimes your justification, like you're missing stuff there. So that's the only hesitation. But yeah, like this, I said I solved this algebraically, but really you could have just graphed it to figure out where it happened. And then I guess you could kind of see this where I just plugged in the numbers. But yeah, your justification still needs to be basically the same thing is what I'm saying. But that's a good question. Anything else from FRQ1? Okay, what is the easiest part of that FRQ? B? Okay, what is the hardest part? C? I agree. C probably took the most amount of work. But everyone's different. Just like the first handout, I do think it's in your interest to maybe circle 1 or 2 things on here so that you can glance back at this later and know exactly what it is. It might be beneficial to look at again. Now, I don't think that's a real FRQ, but I can promise you all those parts of that FRQ often show up on real FRQs. So, okay, to finish up today, again, I'm giving this to you early. It was good FRQ practice for today. We'll do another one on Thursday. We'll do number 2 on Thursday. You are certainly encouraged to work ahead on that, especially if you know that you need to be trying to ace your next test. So you've got that early. But with the rest of class, I'd like you to get out a new piece of paper, number 89. And again, now that we've done the notes on U substitution, And we did 9 or 10 questions together, and you did 3 Khan Academy assignments practicing it. You should be pretty close to feeling good about that. So these last few questions should hopefully get you there where you feel like you've got that process down. So now I will let you guys work on that at your own pace. There's only a few of them that are odd, but I do have them all worked out on my website. So of course you could just pull up the video, go to the end, make sure you had the same answer as me as a quick check. If you don't finish that in class, you do need to finish that up for homework. Part of your homework, I'm asking you to turn in 85 and 89 in the Google Classroom, both of them in the same Google Classroom assignment. 85 was the book assignment that we did together last time, so no reason you shouldn't have that done. So when you finish this part and check your answers, learn from your mistakes, attach it to 85 and turn it in, please. And of course, I will be available in just a few minutes to help out. And of course, if you work very quick, you're welcome to work ahead on your section. Will eventually be assigned a whole new will not be extra work. You need to be doing it early. just be putting in a few homework grades, but again, if you guys have any questions, please let me know and let me help while you're here. A lot easier to get help while you're here than it is to try to figure it out on your own later. Oh, I'm sure you probably don't need this at this point, but I needed to make myself a copy. So, if you'd like to take a picture of the new bell schedule, again, it doesn't really impact our class too much. You still show up at the same time. You still leave when the bell rings, but if you don't have a easily accessed new copy of the bell schedule, you might want to take a picture of that. And I'm going to switch it back to the class agenda in a minute, so if you do want a picture, please do it now.
It is